All right, looks like everybody got a little more coffee after the keynote, so I hear some clapping. That's good. So I'm actually going to be talking about a story, how we actually evolved the platform, built it from the ground up, and essentially scaled it out to what we have. Oil and gas industry. Well, there's a lot of data in oil and gas. Many of y'all know that you probably have terabytes, petabytes of data. A lot of data gets collected, put in your data lake, right? Where does that data go? How valuable is the data, right? Can we get insights out of it right now? Industry is actually moving more and more into the real time. Data lakes is great, but when the data actually gets stored in there, where does it go? What's the value in that? Well, many of our customers probably express the concern of all the data goes into a black hole. Sometimes it gets analyzed, data science team gets their hands on it. Often the value is not delivered to the person that collected the data until 3-6 months down the road, and often they have a lot more questions on how they collected the data versus actually with the insights. There's another challenge with data that's historically driven. How do we keep the data consistent? Many of y'all work with different service providers that store data in different formats. There's a big difference between foot-pounds versus pounds. That's 1,000 in scale. If you don't have the value correctly mapped, that means you're going to be off, and your data aggregation is going to be completely off. If you're going to run ML models on that, you're not going to produce good results. And often the data scientist in the end that's working on the data does not know the difference between kilopounds versus kilopounds. There's also the data problem of time zones. When we collect the data, we think time zones are actually in UTC. Often or not, a lot of the times, we deal with Central Standard Time. And when the daylight saving time comes, some of the sensor automatically corrects that, and some of them doesn't. Which, when you're talking about historical data, when you actually see the time, you actually don't know what's the accurate time. Well, there's also the problem with bad sensors, sensor calibrations, and ultimately human errors. From drilling side, we actually see a lot of data gets miscalibrated. What does that mean? So, for example, when you start drilling a well, what's the hole depth? 0, right? Well, probably a third of the time when we first connect to the stream that from the third party is set at 20,000 feet. Why 20,000 feet? That's probably when they finished the last hole, somebody forgot to put the sensor in there. Well, guess what? You're going to drill at 20,000 feet, and if you keep on drilling, that number is going to increase, and there's no way you're probably going to drill a 30, 40, 50,000 well. Well, we're Corva. We're here to solve those challenges. We're solving the challenges in multiple ways. Number one is we calculate the data in real time. Real-time engineering provide real-time value to the customers. We take the raw data coming in, and we utilize a lot of our engineering capability and the software streamline to provide the data in near real time, probably about 2 to 3 seconds. We also build an app platform where we present the data catered to the end customer, not just the overall architecture of, oh, here are the traces, here are the raw data, but cater to specific, either the drilling engineer on the field or actually the company man or the guy that's actually sitting in the corporate office. We also have an amazing 24/7 support team powered by some of our automated alerts. What do the alerts tell us? Well, if the real data comes in, we're starting the drill, hey, we're looking at 20,000 feet. Well, that's probably incorrect, right? We have rules that notify our ops team, says, hey, why don't we call the drilling for? Are they really at 20,000 feet or are they 0 feet, right? When the bad data comes in, such as earlier the kilofoot pounds or the foot pounds, then we could call the petroleum engineer at the field. Well, did you map that correctly? Is that really kilofoot pounds or was that a foot pound, right? We could correct this data very early on in the process, therefore having quality data going forward. We want to bring the power of real time down to the mobile, right? Therefore, we built the platform to be application driven and also mobile friendly. Here are some of the engineering apps that we have. So if you look at this, the left and the top is actually apps that are determining the accuracy of the well, right? When you're drilling a well, it's kind of like driving down a highway. You're okay to go left a little, right a little, but you want to maintain your trajectory. You don't want to overcorrect it, but you also don't want to go on somebody else's lane without signal first. Some of these apps actually shows how well you're drilling. This is displayed in literally real time to the engineers. The bottom one is a hook load broomstick plot. it represents problems with the hole, right? How dirty it is, how clean it is. When they run a casing down the hole, like, are they going to run into problems? So when the numbers doesn't go flow to the engineer's needs, then we actually could represent the data way before the problem actually occurs. Circulating pressure loss. So this is a good one for detecting errors earlier. So when you have an end-to-end loop, when your pressure is down from the top and the pressure captured from the bottom, we want to figure out what component takes the pressure. And if the calculated value and the actual detected value is off, that means you have a pretty bad leak. So that little chart shows them errors real quick. So now we're kind of going back to the data lake problem. So now that we're doing all this calculation, we're actually also performing real-time aggregations. What does that mean? So right now, if you want to figure out historically how well all your wells doing, you're probably going to have to ask your analytics team to run some reports. Well, we provide all of that in real time. You could actually do real-time driller roadmap, meaning, hey, around this area, what well performed well? What section of the well performed well? What equipment actually performed really well? So for the upcoming well, let's choose the right equipment, choose the better equipment in order to get the maximum performance. There's also metrics apps that we're probably going to show in a little bit to compare, to compare how are we doing across all of our rigs, right? Which crew are performing the best? Which rig is drilling the fastest? Which rig is actually having the lowest non-performing time? And let's go into the demo real quick. Oh, internet's down. All right, we're going to skip that. Sorry. All right, so, how we built this. This is the high-level system architecture where you have your user flow on the left-hand side, where on the mobile, on the web, and we also have an API endpoint that our client can access. The data go through some sort of cloud balancing and then ultimately end up to the API where the data reside on the Mongo database. Well, where's the real-time data come from? It actually comes from what we have is called the WITSML standard. It's a SOAP-based XML service that is the standard for oil and gas industry. We utilize AWS Lambda to consume the data and then feed it into Kafka. The Kafka gets consumed and then feed it back to the API. Well, this is kind of nice, right? Well, here's actually what's underneath the right side of the screen. This is our real-time data pipeline. We utilize a lot of Kafka to Kafka database for the stream level data, and we use a very generic API endpoint to push the data into Mongo database. And we also use a generic API endpoint to push the data into Kafka. If you look through this, we utilize literally pretty much some of the top technologies for the purpose, for the task, right? So if you're on the top, for .NET, obviously, if you want to build XML connectors, for SOAP XML connector, we want to utilize .NET. But as you flow down on the lower levels, we utilize Node.js, Java, and some of the Python stuff for the machine learning. The two endpoints essentially are used 24/7, and we get about 4 terabytes of data going through some of these endpoints. So let's take a little deeper dive into this chart. Earlier I mentioned that we have a lot of problem with real-time data or even just oil and gas data. We have this little core process that's called the core enrichment wrapper. So what does that do? The raw data come in, obviously we store that into Mongo using the little API, but then it goes through a series of kind of a homegrown apps to make sure the data is good. First one it goes through is the ETL app. That actually converts all the units into the proper unit that we expect. Unit comes in from different vendors that are calculated differently. What we want to do is have one type of data that's either standardized to feet or standardized to meters, where we could do our engineering calculation. The next one is a quality validation. Well, that's where we trying to figure out, okay, when the data comes in, is this right or not? And when the data that we think is actually not according to what it should be, we send an alert, right? This is where our 24/7 ops team comes in handy. They will literally call the rig, be like, hey, is your data quality up to par? Like, essentially, they'll be like, hey, is your mud spec up to par? Like, why is this stuff not coming in? Or why is the data off? Then there's metadata association. Well, what is that? We get data from all sorts of different people, right? Including the real-time data, and we have daily PDF reports, we have daily Excels, and the metadata associates the raw data with the hole size, BHAs for bottom hole assembly, such as the motor. So just imagine if the raw data comes in drilling a 12 feet hole versus a 5 feet hole, that makes a pretty big difference. So we want to actually associate that correctly at the right time in order for the engineering calculation to be accurate. Earlier I mentioned we have a depth problem. If they don't reset the sensor, we actually purposely build an app just for that, to calculate the true depth of the hole and the bit, and based on all sorts of different parameters. The last but not least is the activity. So when the raw data comes in, it's just bits, right? It doesn't actually tell you what it's doing. What the activity detection is telling you, hey, are you actually drilling? Are you cleaning the hole? Are you tripping in and out, right? Are you turning? Are you sliding, essentially? So after all of that, that goes to the enriched data. And the enriched data is where most of our APIs actually hit. But at the same time, the enriched data is getting piped into this with Kafka stream, where some of our heavy loaded apps are utilizing it. So one is aggregation. Talked about metrics earlier, right? You can't literally process terabytes of data in real time. So what we do is we pre-aggregate the data into either 30-minute chunks, 1-hour chunks, therefore to utilize in the aggregating framework. There's also the engineering app, so this is where we calculate a lot of the torque and drag, pressure losses. We use Java for that. That's a little bit heavy lifting. That particular app probably generates about 12 collections in itself. Machine learning, we have an ROP prediction. This is where the optimization kicks in. We could train our machine learning algorithm to figure out what's the best ROP, right? Ultimately, you want to drill the well faster, but also safer. So we're able to calculate confidence intervals, different parameters to recommend differential pressures, to recommend speed, to recommend hook load for you to drill faster. The last but not least is the data training app. So the data training app, so right now we have kind of explained that we have alerts that are detecting point-in-time anomalies, such as if a pressure drops down to 0, that's bad, right? But what happens if a pressure drops slowly, right? What happens if there's a slow leak? That has to be a time series detection. So we actually had to build the app to be smartly detect, hey, what happened in the past 5 minutes? And do I see a pressure trend that's abnormal of whatever that's supposed to be happening? And if that is the case, then this will raise an alert to alert the crew. And this is actually some of our kind of a key selling points, because this would detect slow leaks. Many people in the industry know what a washout is, so that's probably a really powerful app. All right, so the platform has enabled us to build roughly about 50 UI apps. That some of them you probably didn't show it on the live demo, but earlier I mentioned that we utilize these apps for monitoring the well, drilling progress to monitor the well health, and we also do real-time engineering for essentially for the guys that are on the drilling floor. We also provide analytics for aggregation framework, so they could literally compare all the historical wells in real time. Last but not least, right, we utilize ML to perform optimization. All right, so why MongoDB? We're at a MongoDB conference. Well, MongoDB enables us to actually have a flexible schema at the app creation. We don't have to define what the data looks like when we start building an app, right? At the data coming in, we could calibrate, okay, our app needs to have some required fields, but some of the stuff doesn't need to be there yet. Let's just kind of leave it as it is. We could customize the data per stream, such as one vendor have, for example, 460 data points per every single second, versus the other vendor will have 20 data points per every second. Well, with more data, you're going to produce more value, and you could do more calculation on it, and versus lower data quality or resolution, you cannot do as much. Data can be enriched in the middle of a stream. What does that mean? Well, as soon as you start drilling, you might only have a limited of parameters that are coming in, but as the data goes, as you're drilling deeper, you actually might get additional data that are coming in. So when the data comes in, even in the middle of the stream, our apps are able to detect the data and then do real-time calculation on top of it. Here's a kind of an example of what our data looks like. This is the same schema literally across every single one of our collections, which we have about 60 to 70. You know, you always have your Mongo primary ID, your timestamp, and your version. We want to track of the version because you don't want to ever compare version 2 with version 3, right? You want to compare apple to apples, not apple to oranges. The data package, this is where this it's actually really flexible. Those are kind of required field, where within the data field, you could literally customize as much as you want. Because we have the same schema across all collections, we literally only have one endpoint for data that's going in and out. So every single API request from the web UI, from the mobile UI, from our client, from the data apps, go through one API endpoint to get the data in and out. So MongoDB also enables to grow very rapidly. Right now, as we're seeing, our database has probably already grown a few gigabytes. We grow at 100 gigabytes per day for that particular collection. There's about 4 terabytes of data going in and out of our system through the API. How do I get that metric? AWS bill. So we take the total number of data that's going through the API, and then we divide by 30. Right now, as I'm speaking, one collection of data has 5 terabytes of data. That's a lot of data, right? You can't theoretically get all the data out in the same time. Therefore, we build the aggregated collections to get some of the data out in a reasonable time. MongoDB allow us to shard. Well, sharding is the key for data growth. We're able to shard and grow at the exponential growth that we are, and we're probably planning on adding additional shards. There's a theoretical limit, and we're still trying to figure out what that is. So right now we're growing about 100 gigabytes a day. By the end of this year, we'll probably hit about 200 gigabytes a day. That's the projection. Response time is key, right? You never want to have an app that's slow to response. People are impatient now even more than ever. With MongoDB, with properly tuned indexes, even hitting that 5 terabytes of data, we're looking at reasonable response time. We're not looking at 20, 30 milliseconds, but within a few seconds to get the data that you want, it's reasonable. Price per storage. I worked with different database solutions in the past, in my previous lives. Come from MongoDB to any other database solution, where you're looking at a 10, I think we're at 12 terabytes right now. MongoDB is probably offer the best pricing. So how do we scale this? When we build the application, we did not plan to be this fast growing, believe it or not. So over the past year, we had to really figure out how to optimize our queries. So because we have one endpoint to get the data in and out, so every collection must have this index, which is the primary ID index, not the Mongo primary ID, but a primary asset ID, and plus a timestamp. Therefore, it gives a general idea of, hey, if I want to get data for this asset ID from this time, it gives them the ability to do that out of the box. We utilize quite a bit of partial indexes because of our data size to perform rapid responses for ad hoc queries, so call it. Some of the alerting rules require quite a bit of a partial index to get the optimization they need, because if a query runs more than 20 seconds for alert, well, that alert is no longer really crucial anymore. We also had to kind of educate our consumers of the API to utilize some of the indexes. So we have a published kind of a little list of hey, here's some of the existing indexes that we have for Mongo, and here's the one that you probably should use for different case scenarios. They don't always listen, our UI guys, but when they do listen, their query performs much faster. And if they don't listen, it'll just kind of wait there forever. We also have a 20-second timeout, so we can't have a lot of runaway queries hitting the database at the same time. Often or not, we actually do have to create new indexes for different purposes. This is more for newer apps that are being built. Hey, we needed this index to serve this purpose, but now I'm trying to think, okay, so add another few hundred gigabytes of one index is pretty massive, so what can we take out? So now we have to educate the team of, hey, we're adding an index, let's try to consolidate, maybe removing one or additional index on top of it. So yeah, one of the lessons we learned, building an index on 5 terabyte database, it takes a while. Shard. Well, this has probably happened about 3 quarters ago that we had to go into shard. So Mongo has a storage limit of 4 terabytes for any given database. I don't know if you guys know that, but we were pretty close to it. At that time, the only option is to shard. So we're trying to figure out shard keys. That's a little bit tricky, right? Like, what do we want to shard with? So naturally, we're going to do the primary ID plus timestamp. But if you think about that, the primary ID is a monotonically growing integer. So if you do that, then you're going to have a very interesting balancing in shard. If you guys kind of have that challenge, well, we ended up is kind of trying to randomize the primary ID. So therefore, when the data does grow, it doesn't hit one cluster at the same time. And I think Mongo actually does a pretty good job behind the scenes of balancing the clusters within the shards. We want to keep the shard key consistent. This is more of a documentation purposes because when people utilize your system, you don't want to have them like, hey, what is the primary key, or what is the primary shard key for this? And how do I write my query against it? So if you want to have a large collection size, such as 60 to 70, you want to keep it consistent. There are exceptions. One of the shard keys that we had to kind of hack around is our metrics. So if you think of our metrics, we compare against wells, but not just only wells, across different programs, BHAs, rigs, whole sections. So when you're running a metrics like that, you cannot just have a primary ID plus timestamp key. Timestamp actually is relevant for that matter. It's a time range. So for that particular collection, because it's very weird on the use case, we had to use a hash key for sharding. So what does that mean? It means the key is not being indexed, which means every single query for that particular collection goes across all of the shards. It does reduce load when you're sharded, but you're looking at the performance gain not as much as you actually had a primary key that's for the most used index key for the sharding process. Well, kind of talking about a little bit about the data-driven platform. Well, our data-driven platform allow us to customize the pipeline. I kind of show you a bigger picture of the pipeline. There's more stuff added to it, and you can also remove stuff. So if you want actually data that are faster, that are more like less kind of calculation, you can actually achieve that, right? You're looking at maybe a second saving, but sometimes people want that. If you don't need the ML capabilities, we could just kind of take that away. It's a configuration variable, then your pipeline doesn't have it. But the more powerful thing is you could start adding apps. So say one of our R&D engineers start building an app, says, okay, I want to test this particular app, data app, only on this particular well. Well, that's actually literally a 3-click, right? You click the plus button, you add the app, and then he's already there, right? Only for that well, now he has the data that he wants to get the result he wants. And now he could test it, he could iterate it. This enables a very fast approach of how to manipulate data. There's no code deployment whatsoever to enable that feature. Also, one of the features that the Flex Schema API. So earlier I mentioned we have one data endpoint. It's literally this, right? /data. You could get data, you could put data, and the data provider's in there, and the collection is in the URL. This enabled us to optimize that one endpoint. Say we want to change anything. Well, we have to, do we really need to change the endpoint, or can we just change how the behaviors? And using this type of endpoint, we're able to essentially satisfy 99.999% of the queries without creating additional endpoint. We do have other endpoints, but they're used very infrequently. All right, so kind of the potholes along the way. Well, we run into probably quite a few iterations, including some minor outages of our entire system over the past year. Knock on wood, we have less crashes now. Capability come with responsibility. So what does that mean? Our API, the one that slide I showed you earlier, one endpoint get in and out of data. Well, if you don't put a limit on that, what could happen, right? One bad app could completely crash your entire system. So since then, we actually had to introduce index-only query limits. So it's a feature in Atlas that we utilize, which means if you send a request, API request into the database, and you don't have an index already in there, well, MongoDB can't find the index, it just rejects it, right? So therefore, you don't have to do a full collection scan on 5 terabytes of data. Another thing is limits. We only allow clients to get about 10,000 rows data at the same time because, let's say if somebody write a bad query, it's like, oh, I want to do the start timestamp is like beginning of time, and the end timestamp is like later, and then I want the asset ID like 100. Well, that's about 2 to 3 gigabytes of data per any given asset, some are more, some are less. We don't want to return that in one fell swoop, and the response time is not going to be there. Along the ways, we had to tune MongoDB. We briefly talk about indexing. Aggregated collection is a crucial piece to enable a steady response time for our metrics collections. Aggregation, we had a little pipeline over there, so we pre-aggregate like every 30 minutes, every hour, every 6 hour. I think that's probably around the timeline. Sharding is kind of interesting. So we went through the roadmap. We waited until the last minute to shard, simply because one, we didn't have the capacity to actually do a lot of R&D, and then two is that we actually learned quite a bit of our user behavior and the query performance when you're not sharding. So we know when the pinpoint is. Therefore, we could basically choose a shard key that's more effective for our use case. So I don't know if you guys know this. Once you choose a shard key, you cannot change it anymore. I don't know if that's a change that MongoDB is going to release in the near future, but I really do appreciate that if that's the case. Lambdas. We kind of went through the pipeline about AWS Lambdas. It's a serverless product that AWS released. Essentially, you don't release code into the actual physical or virtual machines. You release the code into this Lambda components, and this component essentially has input, output, right? You invoke it using an event or data, and the output either write the data to the database or pass the data to somewhere else. We hit 500 million probably a couple of months ago, and that's a lot of invokes. AWS loves the bill, at least for that. We actually had to figure out what's going on with code and worm invokes. So code invoke meaning you have never invoked this before, and for the first time, and a Docker image literally have to spin up. So you're literally waiting. And worm invoke is you already invoked it once, and then it's kind of sitting around, and then when you invoke it the second time, hey, the Docker image is already there, so you don't have to wait for the spin up time, then you could just get your data in and out. For us, we had to figure it out, hey, when the exception happens, AWS treat that as a bad container, which means when you have a series of exception happens, now every single invoke is cold, so therefore our latency just skyrockets. Logging. It's a kind of a pain for us with Lambdas. So for every Lambda invoke, you have to have at least 2 entries of logging. So first is the start timestamp, and the second is the end timestamp, and they will actually tell you what your bill is, your duration, and how much resources used. That's about 1 billion lines of code right there, and probably across hundreds of thousands of log streams. So we had to figure out how to get that down to a maintainable level. Last but not least, we do utilize Kafka quite a bit. We had to figure out what's the right balance between topics and partitions and consumer. The reason we chose Kafka is because we just couldn't afford the Kinesis bill anymore. Kinesis is a kind of competitor to Kafka, but hosted by Amazon. The selling point of Kinesis is that you don't have to maintain it, but we're going to charge you a lot for it. So I kind of briefly talk about drilling, but ultimate goal is to have the platform built around the whole entire oil and gas industry. So we're pretty good at drilling, I would call it. We started off with a few rigs starting of last year, and then now we're about 200 plus, and our goal for the end of this year is 300. So to give you an idea, that's roughly about 25% plus market penetration for the entire North America. We just launched our completion product in about, I would say probably a month ago. That product actually has a few more streams, not as complicated as the drilling one, the one that I showed you earlier. And then we're slowly moving into the production and the reservoir. So this app platform enables us to do all of this. Some of the future thoughts for MongoDB, right? So we have a lot of data, 5 terabytes data that's growing faster. We can't maintain it, to be honest. Like, we have to figure out a way how to kind of consolidate that data. So if you're on the talk earlier with Robert, so the IoT schema is definitely something we're looking into. We're looking to how to consolidate data into smaller chunks. If you consolidate the 1 second series data into a 60 second, if you think about it, that's 1/60th saving number of documents. What does that actually mean? So yeah, you're storing the same data. You're maybe saving a few percent in actual data storage. But the key is indexes. If you save 1/60th of the document count, you're literally saving 1/60th size of your index, which means your index is so much smaller, you could run queries so much faster. Atlas Stitch is another area that we actually want to investigate in. We're sold on serverless, right? Like low maintenance, low servers, like there's no maintenance really, so you just kind of deploy it and it sits there. We're using Atlas functions to enable some of our automation framework. We're automatically parsing emails in and out, we're automatically parsing Excels, we're automatically parsing PDFs. We're trying to kind of automate as much as the manual process in oil and gas as possible. I still can't believe that we're still sending back and forth the PDFs where the data resides on a database, and they don't want to expose any API endpoint, so they have to generate a PDF report, which is pretty time-consuming, email it to us, and then we have to consume the PDF, parse it, and then put it in the database, where we could just probably connect that relatively easily. We also use Stitch for some of our workflows. So like, if the ops team has a different workflow that they want to automate, right? Stitch is a great function for it. Currently, it's only internal use only, but we're exploring the option of exposing Stitch APIs to some of our clients in the near future. And there we go, Q&A. So if you do have questions, we actually have gifts for you. So we have little bottles of Nalgene bottles with stickers. So anybody who asks questions could get one of those. Otherwise, you guys could go to lunch.
So if you have a question, lunch will be there no matter whether there's questions or not. But if you do, raise your hand really high, and I'll come bring you a mic so we can all hear you.
I think we got it over there in the back. Sorry.
Okay.
We're actually using a kind of a self-hosted hybrid producer. We're not using the managed Kafka from Amazon. That's just recently been GA'd, right? Is that what your question is? Yeah. There's a lot of limitation with the Amazon hosted ones, more of like how do they expose it, and they don't use the latest version as well. So that's still in the roadmap. Once they mature the market, we'll probably use them, but we're currently not.
Okay, hold on. Let me bring you the mic so everyone can hear, and it's on the recording so that they can hear your awesome question.
What version of WitsML do you use?
What was that?
What version of WitsML do you use?
Right now, we could use 1.3 and 1.4. So, but it's not on this slide. We're actually deploying an IoT platform down at the field level as well. So WitsML actually gives us quite a bit of data latency that our customers are not super excited about it. We're looking at anywhere between 10 to 40 seconds, up to 40 seconds. But with our stream box, we call it, it's a little box literally connected to the rig, and then we have sensor data flowing in. We're able to cut down the total round trip from data collection to displaying on our platform to about 2 to 3 seconds. So, and going through all that little widgets.
Any others? Okay, let me get over here. I'm going to cut through here. I'll just do this action.
A reason for selecting the AWS over other cloud platforms?
Sorry.
A reason for selecting AWS or going for the AWS?
AWS?
Yeah.
Like, why do we select it?
Yeah.
I think they're the bigger market. So one of the key things you saw that Lambda, so the serverless model, so AWS has, lack of better words, nowadays perfected it, what it is, right? So we can't scale our platform without the Lambda. We're definitely looking into a way to kind of compartmentalize that into a Docker kind of a container Kubernetes system. That's on the roadmaps, but right now that was the lowest barrier to entry in order for us to grow the scale that we are. I mean, like any system that has 500 million invokes per month, probably, it requires a lot of time to build that infrastructure up, for lack of better words.
Okay, we have another one over here. I hope you have a lot of those water bottles, because you're getting a lot of.
We got it.
Are you using the MongoDB Atlas charts or a different visualization library?
We're not using charts. So we built this platform, at least first envisioned out, probably about a year and a half, 2 years ago. So Atlas charts, I don't think was really present. And plus I didn't really get a chance to show it, but some of our visualizations requires a lot of customization as well. So like kind of just give you this. Charts are pretty powerful, but I don't think chart could render these kind of plots that we do. That essentially, this is the bread and butter of a petroleum engineer like drilling. Some of this stuff, it's very customized. We use quite a bit of chart library. I think our rendering actually takes quite a bit from our engines.
Any others? Raise a high. Okay.
Yeah, everybody want those water bottles.
More?
That's good.
Yeah, water bottles, man, it does it. Gets good questions going.
I'm just curious about one of the slides you had up there where it was the one which had tons and tons of icons on it.
Yeah, sure. I'll pull it up. This one?
Yeah, sure. That one works. Some of those processing pipelines, there was like an ETL stage and a bunch of ETL
This
apps
one.
and
Yeah.
a bunch of these things. I mean, each one of those is your own instance. It's a specific function.
Yep.
How do you handle like versioning, or if you had a bug in one of those things and it was using the wrong unit or converting something incorrectly or offsetting timestamps badly?
Yep.
What happens? Do you regenerate, replay, reflow?
Yeah. So this is actually a really good question. So what happens when you're like figure out, hey, you had a problem, right? We had this magic button on our well stream. It's called rerun. It's very costly to us because it reruns the whole entire data pipeline. So if you're at the end of the well already, right, you figure out something's wrong, you literally just go in there, okay, that was supposed to be foot-pounds versus kilofoot-pounds. You change the unit, and you hit a rerun. Hopefully, this is the best case scenario, that somebody caught this error early enough where the rerun process is very little, right? So if you imagine rerun like a couple hours versus rerun 20 days, it's a pretty big difference. So our 24/7 ops team actually catches this really early, and then what they do is, oh yeah, that asset has the wrong units. We'll just kind of like put a note on there for the customer, hey, wrong mapping because somebody provided the wrong data. The rerun is in process, and usually reruns happens about 20 to 30x through the pipeline. So, for an hour, you catch it up in 10 minutes. They would switch the ID out so the customer sees the new asset, be like, oh, we're good. Actually, more often or not, when they first start drilling, the customer doesn't even notice it.
Raise it high if you got any questions. Oh, you're so conveniently located.
So on the pricing, you said that you switch out Kinesis. How much of a managed services did you save about? So from using Kinesis and stuff.
So we switched over Kinesis probably about a year ago. So this is kind of a bit of a, so when we switched over from Kinesis to Kafka, I think was a saving of at least 4x. That was also 4 years ago. We also grown quite a bit. So that 4x means quite a bit. But AWS also kind of like the note, the guys that are managing the hosted Kafka from AWS actually will tell you it's in their block. Kinesis out of the box, it's great for like great performance. But if you want true, actually like purposely tuned performance, Kafka has way more tuning parameters. So you can actually perform this much better using Kafka. Know where you're doing it. But out of the box, Kinesis is a little better.
Okay.
Sorry, Robert?
Another one here. Is it another witty Witzmal? We're gonna.
It's WITSML. So the WITS is like this old kind of serial port with 0, and then they're like, oh, let's like, yeah, like serial port, and then they're like, oh, we need to webify a serial port. So like they just kind of concatenate WITS with XML to WITSML. It's kind of fun.
Back on one of your slides, you talked about that you're generating about 100 gigs a day. Is that based on those 200 wells, and what are you anticipating that's going to grow to when you hit 300 plus?
So yeah, earlier we mentioned, so we're also building more apps, right? Apps generate more data. So right now we're going at 100 gigabytes at roughly 200 wells. So at the end of the year, I kind of mentioned we probably target about 200 gigabytes. So that's a combination of increasing in number of wells and also offset wells. So whenever we roll on to customers, we're able to absorb quite a bit of the offset wells, meaning like, hey, I want to compare all the wells that I've already done. Those are usually less data frequency, so we absorb those, be like, okay, at the first day when you utilize Corva, you're actually able to compare metrics now. So a lot of the data is coming from that. So as more customer we rolling in, the faster we're actually growing. So 200 gigs a day, yeah. Makes Alice happy.
Another question over here.
So did you just mention that you had an edge device that circumvents the WITSML entry point?
Yes, that is. So we have the edge device for both completions and drilling. So for drilling, it's WITS 0 that feeds out to us. We completely bypass its XML, the ML thing. put it in JSON, feed it back to us using a very nicely closed loop. For completions, we're able to provide, essentially, we invent our own wheel, right? Because completions, it doesn't have any standard, really.
Any last questions? Okay. Fabulous. Put your hands together for Jim. Really appreciate it.